Hi everyone, my name is Muhammad Sirajuddin Alwi Berosli. My matrix number is AA240594. Today, I will be discussing about the concept of free fall in physics, a fascinating phenomenon that highlights the fundamental principles of motion under the influence of gravity. To begin with, free fall refers to the motion of an object that is influenced solely by gravity with no other forces such as air resistance acting on it. In such conditions, the force acting on the object is described by the equation F equal to mg, where m is the mass of the object and g is the acceleration due to gravity, which is approximately 9.81 meter over second squared near the surface of the earth. To describe the motion of an object in free fall, we use kinematic equations for uniformly accelerated motion. These include v equal to u plus gt, which relates to velocity and time, s equal to ut plus 1 over 2 gt squared, which connects displacement, time, and initial velocity, v square equal to u square plus 2gs, which links to velocity, displacement, and acceleration. Through this equation, we can predict and analyze the behavior of objects in free fall under various conditions. To sum up, free fall is not just a simple concept, but a profound illustration of how gravity operates consistently, independent of mass or shape in ideal conditions. Understanding it lays the foundation for exploring more of the topics in physics. Okay, the key idea here is that in an ideal situation of free fall, gravity is the only force acting on the object and it pulls the object downward toward the center of the earth. This means the velocity of the object increases by 9.81 meter over second every second, regardless of its mass or shape. Interestingly, even if an object is moving upwards, let's say it is thrown into the air, it is still experiences gravity pulling it downwards, causing its velocity to increase until it changes direction and it starts falling. Now, one of the most remarkable aspects of free fall is its independence from the mass of the object. Galileo famously demonstrated this by postulating that in a vacuum, all objects fall with the same acceleration, regardless of their weight or composition. This principle is fundamental to understanding the universal nature of gravity.
Assalamualaikum and hi. Thank you, Sirajuddin. My name is Muhammad Ridwan bin Asmizam and I will continue to discuss about the methodology of our project. So basically, we are using three simple apparatus, which is stress ball, measurement, 3-meter measurement tape, and a mobile stopwatch, because it is convenient to use and easy. So next is the procedure. For the setup, first we find a location with a sufficient height. We use our hostel hallway to minimize wind disturbance. Also, we chose our hostel hallway because it has a sufficient height and it is very suitable to conduct a simple experiment like a free fall experiment. So next, measure and record height of 1 meter, 1.5 meter, 2 meter and 2.5 meter as the manipulated variable. Second, number 2, drop the ball. First, we are holding the ball at the measured height and release it without applying force. Like this book, we just release it without any applying force. So next, we are going to start the stopwatch as the ball is released. Number 3 is to record the time. So when the ball hits the ground, we are going to stop the timer immediately and we will repeat it 3 times per height and calculate the average time. This is to make sure that it is comply with the free fall mechanics and theory. So next is the experiment execution. So this is how we conduct the experiment. You see Farish as the ball releaser at the certain height of 1 meter, 1.5 meter, 2 meter and 2.5 meter. So that's all from me. Thank you very much.
Assalamualaikum and hello everyone. My name is Muhammad Nur Iman bin Zainal, number matric AA241071. So I will explain to you the result and discussion for our group project physics. So our team have choose a free fall experiment. The free fall experiment aims to study the motions of an object under the influence of gravity alone, neglecting air resistance. So the theoretical basis for this relationship is given by the kinematic equation. So as you can see, D equals to 1.5 gt squared, where D is the distance fallen, T is the time of fall, and G is the acceleration due to gravity, that is 9.8 meter per square. So in this experiment, measurements were taken for different heights, that is 1.0 meter, 1.5 meter, 2.0 meter and 2.5 meter. Using these values, the squared times, that is T2, were calculated and plotted against the height. So basically we want to avoid parallax error, so we do an average time to make sure our data following the free fall theory. And that's all from me. Thank you.
Next is my turn. My name is Muhammad Farish bin Muhammad Faisal, matric number 240831. Today I will explain about the graph. First, we see the diagram, the free fall experiment, the distance vs the time squared. The relationship seems to be linear with a line with expectation for free fall under constant acceleration. This indicates that the result aligns well with the theoretical model of free fall. The graph plot the height in meter of the free fall, filling for again the square of the time in second. Also, in the diagram, we see the data point is blue circle, suggests the linear relationship between the height and the key observation on the right, the linear relationship. The text explains that the linearity of the graph is consistent with the theoretical model of the free fall under constant acceleration due to gravity. This supports the expectation that the height covered by a freely falling object is proportional to the square of the ellipse time. Unlike human with theory, the result aligns well with the theoretical equation of the motion under gravity, where is the acceleration due to gravity. In short, the experiment confirmed the theoretical model of the free fall, showing a linear relationship between distance and the square of ellipse time.
Next, we move on to the conclusion. We investigated the motion of objects in free fall. The results obtained were consistent and accurate, with measurements closely aligning with theoretical predictions based on the acceleration due to gravity. The observation demonstrated that in the absence of air resistance, all objects fall at the same rate regardless of their mass. Overall, the experiment successfully validated the key concepts of free fall and provided an excellent practical understanding of the underlying physics. Minor deviations observed were likely due to systematic or instrumental errors, which were minimal.